All right, I'm going to show you how to make a regular hexagon. Remember, a hexagon is a six-sided polygon. A regular hexagon would be a six-sided polygon with six congruent sides and six congruent angles. So all I'm going to do is I'm going to make a circle. And again, this length is completely arbitrary, meaning you can make it long or short or doesn't even matter. So I'm just going to make it that, and I'm going to make a circle with the center of that dot. And I do think twisting the paper's probably the easiest. Okay, so there I have my circle. I'm going to go to any point on the perimeter. So just make a point here. Doesn't matter. Any point on the circumference of the circle. And now I'm going to keep this same radius, and I'm going to make a tick mark, and I'm going to keep going around my circle here. Try to be as careful as possible. And one more just for fun, right there. And then if you look at this, what I've created is six congruent line segments, right? All of these line segments were in fact the radius of my original circle, okay? So I'm gonna put dots on these intersections, and then I'm gonna use my straight edge to carefully connect. Okay. You just go around the circumference of this, connecting, and what we know is all of these lengths are the radius of the circle, and it does turn out that that will form a regular hexagon. It will be six sides. All six sides will be congruent. All six angles will actually be congruent. And based on that, looks pretty solid, right? So all of these sides are the exact same length. They happen to be the length of the radius of the circle I drew. So there's my regular hexagon, and we can talk about the angles. It turns out that all of these angles are 120. That's the interior angle of a regular hexagon. If we went this way and extended aside, this would be the exterior angle, and that would be 60. Be kind of how many turns, right? Turn, 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 turn. You would need 6 turns of 60 to go around the exterior. Other things we could do with this, we can actually connect these middle ones, or actually doesn't matter, we just skip one. So we can actually connect these two. Skip one and go to the next one. And skip one and go to the next one. And it also turns out I formed an equilateral triangle. Okay, this triangle, or excuse me, that side, and that side are congruent. So not only do I have a hexagon, but I also have inscribed equilateral triangle within that guy. Okay, so hexagon, regular hexagon specifically, and then even within that, I can form an equilateral triangle.